Because obviously I could have done the left side and come up with a different equation there and replace one of these two with that. Questions about these two equations or pointing out any mistakes that I just made? We will assume a certain perfection there then. At this point, it's a math problem. So let me do the mesh analysis just to get those two equations. So that one's going this way, resistor, resistor, going that way, resistor. Those two going up, and then, so it's 9, 7, 5, 8, 6, 3, 7, 4. All right, mesh analysis, I'm just doing the whole loop. And just for something different here, I'm gonna make one of them, let's do that one as one loop. Let's call that E, and this one F. Again, the direction I draw it is arbitrary, and as long as I do 2 of my 3, I'm good. So I'm going to start here and work my way this way. So 8. I'm going against E at this point, so minus plus 3E. I'm going to go up, plus 6. Going across this one, I am gaining 7. So I'm going with F in the direction, so minus 7F. Plus 5E equals 0. And then, now you might be wondering, oh, didn't we just save some time because I don't have a resistor with 2 currents going through it? Not really, because I just shifted which one is going to have 2 currents running through it. So let's do the right side. So I got 4. Here I'm going against the current for both F and E. So plus 9F, plus 9E. Down the middle, plus 7F minus 6 is equal to 0. 2 equations, 2 unknowns, and again, it becomes a math problem. Now, for those who have not solved it yet, I do recommend that you do work through it. But there seems to be general consensus that across the 3 ohm, you end up with 1.0995 amperes to the right. For the 5, 1.0995 amperes to the left. For the 7, oh, I did it in reverse order. Oops. And 0.743 amperes up. 0.356 amperes to the left. And then the voltage across the 9. If I'm going with the current, I'm going to lose. If I'm going against the current, I'm going to gain. And so, just make sure your signs are working. 3.204 volts going against the current. Or any of these, you can put a minus sign in front of it and flip the direction. Brooke?
Question, for the mesh analysis, your first equation, you said that was for the entire thing, right?
This one was,
Because it looks like it's only.
no, this was left loop.
Okay.
I did my current, the current loop was the whole thing, but my voltage loop was just left.
Oh, okay.
When I've done mesh analysis in the past, and all the examples I've ever done, I think, I always choose this loop for one of my current loops and that one for the other current loop. And I thought, what the heck, let's just try something different.
Okay. I guess I'm a bit confused on the difference between, you said a voltage loop and then a current loop, right?
The current loop, when mesh analysis, the current loop is how I'm defining the direction of my currents.
Okay.
The voltage loop is how I'm writing my equation.
Okay.
Just like over here, I defined the direction of current, and then I picked my voltage loop, the one where I come back to where I started, my total voltage should be 0.
Okay. Okay, thank you.
And on that note, have a wonderful day. And Harrison, I don't know if you caught the dates. Oh, no, you were here for that.
I got him.
Freddie,
Ready.
I don't know if you caught the dates up there.